Hello everyone, welcome back. So last time we really looked into what happens when we have, a radioactive species that's being produced and then decaying into something else, because we're trying to figure out, okay, yes, I know how one radioactive species decays, but what about the thing it's turning into? Does that matter too? Is that also radioactive? So now we're going to start looking at how we can start calculating the activity and the decay rate and the amount of the species for that daughter species. So we talk about generations when it comes to radioactivity. So we have something that is the parent. And so that is what is first decaying. And then what it produces is the daughter. If that decays, then it produces the granddaughter. And it can keep on going down and down and down and down again. In this case, I'm just saying that the granddaughter is stable. Now, we can use our generation equation we had earlier to figure out how much of that daughter exists with time. And it's pretty simple, honestly. All you're doing is you're saying, okay, however much the parent is decaying turns into daughter, and you're going to subtract from that how much of the daughter is decaying and turning into the granddaughter. So you're just adding one term that adds and one term that subtracts. Not too bad. However, there is an issue. Parents don't necessarily decay into just one particular species. For example, I might have a parent that can decay into two daughter species. And so we had to introduce this new value f, which is simply my fraction that is going for that particular daughter. In this case, since I have two daughters, I'm going to have just f for one and 1 minus f for the second, but I could have 3 or 4 different daughters. It doesn't have to be one particular species, or sorry, two particular species. Now, if we're assuming there is just one daughter species, we're only going to care about that one for now, we can solve and get this particular differential equation. This f right here is saying, okay, what fraction goes to it? And everything else is all about how quickly is the daughter decaying relative to the parent. So, for example, this term right here, this is coming from the parent. That is what's being generated for this daughter. That's adding on to it. And this term right here, pretty simply, that is what is decaying from the daughter. So as the parent creates the daughter is also decaying. So I have one that's generating and one that's removing it. Now this equation is really, really cool because there's actually 3 different cases for what will happen with this equation and the forms and solutions you'll get for it. And they're all dependent on how long the parent lives compared to the daughter. If the parent's very, very long lived compared to the daughter, that's one case. If the parent is just, a little bit longer lived than the daughter, that's the second case. If the parent is shorter than the daughter, that's the third case. So all of those are things we're going to have to look at in the next video. So we'll stop here for now. Thank you for listening. And next time we're going to jump into the different forms this equation takes. We have those 3 cases. See you soon. Bye-bye.